Hi everyone, this is Mrs. GA, and today we're going to be defining and evaluating basic trigonometric functions. Alright, I have a quick warm-up for you guys, so please pause the video and give it a try. Alright, so here is our filled-in unit circle with the angle measurements in radians and degrees, and also the coordinates of all of those points on your circle for those different angles. So please check these carefully. I'm going to be referring back to this a lot during this lesson. It's really important for what we're doing today. And if you need some extra practice on this, you could always draw your own unit circle. I'd say try to commit this to your memory, like be able to recreate this without looking at your notes or using the internet. All right, so today we're going to be evaluating expressions that are using our 6 trigonometric functions, which we reviewed in a previous lesson. So remember that sine, cosine, tangent, cosecant, secant, and cotangent. So here are the ratios of those 6 trig functions. So you can remember the first 3 with SOHCAHTOA, and then the following 3 are the reciprocal functions, and they're lined up with their matching functions. And then another thing that might be useful for us today, which I will refer back to, another ratio that we could create for tangent is actually sine of theta over cosine of theta. So if you think about it, the sine of theta is opposite over hypotenuse. That's the sine ratio. The cosine ratio is adjacent over hypotenuse. So if you simplify this, you end up with simply opposite or over adjacent, which is our ratio for tangent. So an additional way you can think about tangent is sine over cosine. And just remember, for whichever angle you are working with, though the hypotenuse is always opposite the 90-degree angle, and then the opposite side is across from your angle, and the adjacent side is touching your angle. All right, so a huge part of this unit, especially this lesson, is being able to evaluate the trig functions of our unit circle angles. So those angles that you see in the unit circle. So the 30, 45, 60s, and then the ones on your axes like 0 and 90. So we're going to start with just the ones that are in that first quadrant of our unit circle. And we're going to see if we can find, we'll start with sine, cosine, and tangent only of 30 degrees, 45, and 60. So there's different ways that people do this. Some people rely really heavily on the unit circle to do this. I'll talk about that in a little bit. But a lot of people like to reference their special right triangles to help them complete these ratios. So remember, if you have a 30, 60, 90 triangle like you see here, the ratio of the sides will always be 1 to root 3. So the side opposite your smallest angle is 1, the side your hypotenuse is 2, and the side opposite of 60 degrees is root 3. And then we can use this to help us evaluate sine, cosine, or tangent for either 30 degrees or 60 degrees. So let's do that. If I'm doing 30 degrees, let's say, we know sine is opposite over hypotenuse, so the sine of 30 degrees is 1/2. Cosine would be adjacent over hypotenuse, so root 3 over 2. And tangent is opposite over adjacent, so 1 over root 3. And if we rationalize that, we would write it as root 3 over 3. Now let's do our 60-degree angle since we have this already filled out. So again, we're going to do the same thing, but we just are working with a different angle. So in this case, the sine is root 3 over 2. The cosine will be 1 over 2. And then for tangent, it's just root 3 over 1. So simply root 3. Now to find the 45-degree angle for sine, cosine, and tangent, we could use our other special right triangle, our 45, 45, 90. And remember, the side lengths for this would be 1, 1, root 2. So again, we could use either angle to help us with this. So the sine will be opposite over hypotenuse, so 1 over root 2, which we'll write as root 2 over 2. Same for cosine, 1 over root 2, which is root 2 over 2. And tangent is opposite over adjacent, which just becomes 1. So these 9 values Again, you can always sketch out your special right triangles and reference it during a test or quiz, or if you're working on a homework or an activity. It's nice just to have them at the top of your paper. You can always do it. But I would really recommend committing these values to your memory because we're going to be using them so much. It's really helpful to be able to quickly know what the cosine of 45 degrees is or what the sine of 60 degrees is. And really, memorizing them is not too hard because you'll see that some of these values repeat, right? You have 1/2 here and here. You have root 3 over 2 here and here. These are both root 2 over 2. So I would say try to commit these to your memory. I think you're going to be working with them so much you might just naturally memorize them. But of course, you could always use your special right triangles and kind of fill out this table. Now we'll get to the 0 and the 90 degrees in a second, but I'm wondering if you could look at these values really quick, maybe go back to the previous slide. Look at these values here in our table and see if you notice any relationship between the values here and the coordinates of your unit circle. So take a moment to do that. All right, so here I took a little screenshot of just the quadrant 1 of our unit circle. So if you look here, look at your 30-degree angles and you look here. Notice that 1/2 is the y value and root 3 over 2 is the x value. Now look at your 45-degree angle. Root 2 over 2 is the y value, and the x value for both. And then if you look at your 60-degree angle, root 3 over 2 is the y value, and 1/2 is the x value. This is how we can actually use our unit circle to help us evaluate. You might see this connection that the y value of our coordinate represents the sine of that angle, and the x value of our coordinate represents the cosine of that angle. So many people simply will sketch out at least quadrant 1 of their unit circle, and they say, okay, the x value represents the cosine, the y value represents the sine of that angle, and then if you want to find tangent, you can do sine over cosine, or you can do the y value over the x value. So again, we'll say that x is equal to the cosine of that angle, y is equal to the sine of that angle, and tangent is equal to y over x. So y over x equals tangent, because remember tangent, another ratio for tangent is sine over cosine. Now, of course, this is only for our unit circle that we can do this. It's not any circle, it's a unit circle. So I want to talk about why is this happening? So this goes back to the really basic definition of a unit circle, which is a circle with a radius of 1. So let's just take any angle on our unit circle. So we'll just call this theta. So if it's a unit circle angle, that means that the radius is 1, so that's the hypotenuse. That would be like the distance from here to here. Now, if I turn this into a right triangle, like this, we can call this distance from here to here x, because it's directly along our x-axis. So this is x, and if this would be y. And of course, this coordinate, we could call this x, y. Now, if I'm evaluating this angle, here's theta. If I do the sine of this angle, sine is opposite over hypotenuse, which is y over 1. And so that's why the sine of our angle is equal to the y value of the coordinate. And if I do cosine of this angle, it's x over 1, which is why the cosine of any angle on the unit circle is equal to its x value, the x value of the coordinate. And then if you do tangent, it's opposite over adjacent, which is y over x. So the y value of the coordinate over the x value of the coordinate. Or another way of thinking of that is the sine over the cosine. So again, we can use our unit circle to help us evaluate these angles as well. So some people prefer to do this rather than maybe memorizing this chart, or maybe memorizing or writing down the special right triangles. Now for angles like 0 degrees and 90 degrees, you'll notice we can't use our special right triangles to evaluate them. So for these, I really like to use the unit circle, and I like to use these coordinates. These are called quadrantal angles because they are in between your different quadrants. So for these, I like to use the coordinates. So for 0 degrees, remember the sine is the y value, so the sine of 0 degrees is 0 because the y value of our coordinate is 0. Now the cosine we can find by looking at the x value of our coordinate, so that value will be 1. And the tangent is just y over x, 0 over 1 is just 0. Now for 90 degrees, which would be up here, again, the sine of any angle would be the y value from our unit circle, so that's 1. Cosine is the x value, so that's 0. And tangent is y over x, which in this case is actually undefined. So you're going to see later on in this unit when we start graphing our trig functions, the graph for tangent actually has vertical asymptotes because there are many angles where that function is undefined. So again, I would really recommend that you can commit these to your memory. You really only need to memorize your quadrant 1 angles. Because if you know quadrant 1, you can apply them to any quadrant around your axis. So again, I really would recommend memorizing these angles so you can quickly evaluate any trig function by hand. So now let's talk about how we go about evaluating our trig functions by hand. So the first step is going to be finding what is called the reference angle. I'll talk more in depth about this. We'll do this solely finding the reference angle in the next example, but this reference angle is going to be so important for us. We denote it as doing theta prime. That's how you show a reference angle. So by definition, a reference angle is the distance to the closest x-axis. And if you can find a reference angle of the angle you're working with, you can actually evaluate the expression using the reference angle, and you'll get the same absolute value. So the reference angle acts almost exactly like the original angle. However, sometimes the sign is going to be different. And our reference angle should always be something between 0 and 90 degrees. So it's a distance to the closest x-axis. So it's always positive, and it's going to be between 0 and 90 degrees. Or 0 and pi over 2 radians. And then after you've evaluated the expression using your reference angle, we have to check what quadrant our angle is in to determine if our value is positive or negative. So there's a little trick for this. It's ASTC, which a lot of people use the phrase all students take calculus to help them remember. So how this works is the first quadrant is A for all, and then S, T, C, so all students take calculus. So if you fill this in, these letters represent which functions are positive in each quadrant. So in quadrant 1, all of your functions are positive. A stands for all. In quadrant 2, only sine and its reciprocal function, which would be cosecant, only sine and cosecant are positive. So sine is positive in quadrant 2. In quadrant 3, tangent is positive, and then its reciprocal function will match, so cotangent. And in quadrant 4, only cosine is positive, along with its reciprocal function, secant. So this little trick, all students take calculus, will help you determine if the function you're working with is positive or negative in that quadrant. So all, sine, tangent, cosine, and then the other functions would be negative in those quadrants. A quick tip, if you are working with a reciprocal function like secant, cosecant, or tangent, I would actually just evaluate the expression using its corresponding reciprocal function and then take the reciprocal of that answer. So I think that's a lot easier than memorizing the values for your reciprocal functions as well. So if you know your original 3, you can evaluate these very easily. All right, so before we even start evaluating functions, we're going to just focus on how to find that reference angle because it's so important to our process. So again, we're just finding the reference angle here. and we're going to match the unit of measurement to the unit that's in the problem. So remember, it's the distance to our closest x-axis. So if it helps, you can kind of sketch out what's happening with our angle. So 135 degrees we know is somewhere in quadrant 2. Here's 135. And the closest x-axis here would be 180 degrees. So in this case, to find our reference angle, which would be this distance right here, that's theta prime, we would do 180 degrees minus 135 degrees. So our reference angle is 45 degrees. So it turns out that 45 degrees acts a lot like 135 degrees. You can tell a lot about this angle by using its reference angle, 45 degrees. All right, let's look at this next one, 7 pi over 6. So here we're working in radians. So we know that 180 degrees, so right here would be 6 pi over 6. So this is one extra slice. So 7 pi over 6 is right here. So our reference angle is actually this distance. Now we're kind of working backwards. Now our closest x-axis is pi in this case. So in this case, we'll actually do 7 pi over 6 minus pi, which would be 6 pi over 6. So our reference angle is simply pi over 6. And actually, if something is in radians, it's really easy to find our reference angle because it's essentially going to be whatever the denominator is from your original angle. So notice 7 pi over 6, the reference angle is pi over 6. All right, let's look at part C. We have negative 25 degrees. So remember, when we're moving in the negative direction, we go clockwise. So negative 25 degrees is here in quadrant 4. And our reference angle will be this distance. So actually, our closest x-axis would just be 0 degrees. So the distance between negative 25 and 0 is just 25 degrees. Again, our reference angle should always be a positive angle between 0 and 90 degrees. Okay, now if you look at this next one, notice that our angle is actually larger than a full rotation. So in this case, I think it'd be really useful to find a coterminal angle, so a little review from a previous lesson. And we can do that just by subtracting a full rotation, which would be 360 degrees. So we can see that our reference angle here is 60 degrees. So we can actually just use 60 degrees instead of 420 degrees. They will have the same reference angle. Well, and of course 60 degrees is just in quadrant 1. It's right here. So our reference angle will also be 60 degrees because that's the distance to our closest x-axis, which is 0 degrees right here. All right, let's try our next one. So we have 9 pi over 15. So we have an angle in radians. So to place this one, remember 15 pi over 15 would be like half of a circle. So 9 pi over 15 is going to be somewhere here in quadrant 2. So we want the distance between 9 pi over 15 and 15 pi over 15, which is just, 15 pi over 15, which is just pi. So half a circle. So we would just subtract 15 pi over 15 minus 9 pi over 15, and we would get 6 pi over 15, which we can then simplify to 2 pi over 5. So that would be our reference angle. And of course, if you would like to simplify the angle first and then find the reference angle, you can do that as well. Okay, the last one, 5 pi. So that's definitely more than one rotation. So let's find a coterminal angle again. So I'll start by subtracting a full rotation. Still leaves us with 3 pi. Let's find another coterminal angle, an even smaller one, which is just pi. So pi is this angle right here. So since it's actually on our axis, we would say that this one actually does not have a reference angle. So this one has no reference angle. So by definition, our reference angle should be between 0 and 90 degrees. So anything that is on one of your axes will not have a reference angle. All right, so I have a couple for you to try on your own. So if you could pause the video and give it a shot, you can hit play when you're ready to check. All right, go ahead and check your work here. So for the first one, I found a smaller coterminal angle, so 7 pi over 5. So the distance between 7 pi over 5 and pi, its closest x-axis is 2 pi over 5. And then negative 255 degrees is over here in quadrant 2. So the distance between negative 225 and negative 180 is 75 degrees. And then negative 2 pi over 7 is just in quadrant 4, and the distance to its closest x-axis, which is just 0 radians, is positive 2 pi over 7. All right, so now that we know how to find our reference angle, we can try evaluating some expressions. So when we're evaluating any expression, the first thing I'm going to do, again, is to find the reference angle. So if the angle we're working with is 150 degrees, I know that our reference angle is going to be 30 degrees. So we're actually going to evaluate the cosine of 30 degrees, which would be root 3 over 2. Now I need to look at what quadrant my original angle was in to determine if our answer should be positive or negative. So remember, we do that by doing the ASTC. All are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So this angle, 150 degrees, is in quadrant 2. And I know in quadrant 2, if I'm working with cosine, our answer is going to be negative. So our answer for this expression is negative root 3 over 2. Or if you look back at your unit circle, if you find 150 degrees, this should be the x value of your coordinate, negative root 3 over 2. All right, let's try this next one, the tangent of 5 pi over 3. So again, we're going to start by finding our reference angle, which in this case is pi over 3, which is like 60 degrees. So we're going to evaluate the tangent of pi over 3. So the tangent of 60 degrees, if hopefully you'll have it memorized, is root 3. And anytime if you look at something that's in radians, you could always think of it in degrees if it helps. And that's why it's nice to find that reference angle, because it's always going to be an easy conversion, hopefully in your mind, from radians to degrees. So the tangent of pi over 3 is root 3. So now we just need to look at our angle and determine what quadrant this is in. So 5 pi over 3 is over here in quadrant 4. And we know in quadrant 4, only cosine and its reciprocal function are positive, so tangent will be negative, so our answer is negative root 3. So that's the value of this expression. Okay, let's try this last one, the sine of negative 135 degrees. So our reference angle here would be 45 degrees. So we're essentially evaluating the sine of 45 degrees, which is root 2 over 2. And then we're checking the quadrant. So if you're moving clockwise for that negative angle, you're falling in quadrant 3. And in quadrant 3, sine is going to be negative, so our answer is negative root 2 over 2. So again, kind of a coincidence that all of our expressions have negative values, but sometimes our answer will be positive, sometimes it's negative. It depends what quadrant we're in and which function we are evaluating. All right, so at this point you can pause the video and give this one a try on your own. All right, go ahead and check here. So check your reference angle. So in this case, the reference angle is 30, and the cosine of 30 degrees root 3 over 2, and it's positive in quadrant 1. Here our reference angle was pi over 4. The tangent of pi over 4 is 1, and in quadrant 3, tangent is positive. And last here, our reference angle is positive 60 degrees. The sine of 60 degrees is root 3 over 2. And in quadrant 4, sine is negative. All right, let's try a couple problems where the angles fall on our axes. So remember, for these types of problems, I like to use the coordinates of our unit circle to help us evaluate. So I will usually kind of sketch in a little picture that looks like this, because these coordinates are super easy to draw. Because if I'm going exactly 1 unit to the right, this coordinate will be 1, 0. This will be 0, 1. Oops, 0, 1. And then this is negative 1, 0, and 0, negative 1. And remember, the x value is the cosine, the y value is sine, and tangent is y over x. So if I want to do the cosine of 0 degrees, I just look at the x value of my coordinate, and it's positive 1. Or if I want to do the sine of pi, I know pi is this angle here, and so I look at the y value, and I say, okay, that is 0. Or if I want to do the tangent of 90 degrees, that's this angle. And then for tangent, remember for tangent, we do the y value over our x value. So you'll notice here that if you do your y value over your x value, you get an undefined value. If you remember from the original chart we created, that the tangent of 90 degrees is undefined. Again, we have an asymptote there. You'll see a little bit more of that when we start graphing these functions. All right, go ahead and pause the video and give these 3 a try on your own. All right, go ahead and check your answers here. So here you can see, I drew the picture again, but I actually wrote out which coordinate. I was the coordinate of that angle, and then remember for sine you do the y value, for tangent it's y over x, and for cosine it's the x value. All right, let's try a couple more together. So if you look at this first one, we have the sine of 405 degrees. So when I'm working with a larger angle like this, I'm always going to start by simply finding a coterminal angle because they do act exactly the same. The sine of 405 degrees is exactly the same as the sine of 45 degrees. So we're really just finding the sine of 45 degrees, which is simply just going to be root 2 over 2. And this is in quadrant 1, so I know it's positive. So again, by finding that coterminal angle, it becomes a much easier problem. Same thing for part B. Let's find a nice positive coterminal angle. So I can add 2 pi, and we get negative 5 pi. All right, let's add 2 pi again, and we get negative 3 pi. All right, let's add 2 pi again, and we get negative pi, which is not too bad to work with. Or we could add, if you prefer to work with positive angles, sometimes that's a little bit easier. You can do, you can add one more round. So we're simply just finding the cosine of pi. So in your head, kind of visualize what that coordinate would be. That coordinate would be negative 1, 0. And then since it is cosine, we take the x value of our coordinate, so it's negative 1. And last, we have the tangent of 19 pi over 6. So same thing. Let's start by finding a nicer angle to work with. So I'm going to subtract 2 pi, and we get 7 pi over 6. So we're just finding the tangent of 7 pi over 6. So we need to find that reference angle, which will be pi over 6. The tangent of pi over 6 is root 3 over 3. And from here, all we need to do is figure out what quadrant we're working with. So 7 pi over 6 falls in quadrant 3, and tangent happens to be positive in quadrant 3. So our answer is positive root 3 over 3. All right, we're going to try 3 more together. Here we have our reciprocal functions. So remember, for these, I really recommend, instead of finding the cotangent of pi over 3, let's start by just finding the tangent of pi over 3. And then at the very end, we'll take the reciprocal of whatever this value is, and that will give us the value for cotangent. So the tangent of pi over 3, we actually just found that in the last problem, is root 3 over 3. So if you, and this is in quadrant 1, so it's going to be positive. So then if you take the reciprocal of this value, you get 3 over root 3, and then you could rationalize it, and you get 3 root 3 over 3, which ends up just being root 3. So again, work with the nicer function, and then just take the reciprocal of your answer from that. Same thing here. Instead of finding the secant of 5 pi over 4, let's find the cosine of 5 pi over 4. So our reference angle is pi over 4. The cosine of pi over 4 is root 2 over 2. Here we are working in quadrant 3, so our answer is going to be negative. So we have negative root 2 over 2, but then we need to take the reciprocal of that because, again, we were working with secant, so our answer is just negative root 2. Again, we could take the reciprocal and then rationalize. We'll just end up with root 2. Right, last, instead of doing cosecant of 180 degrees, think of it as the sine of 180 degrees. So again, you can kind of visualize that coordinate. That coordinate will be negative 1, 0. Sine is going to be the y value. So the sine of 180 degrees is equal to 0. So maybe you're thinking, well, what's the reciprocal of 0? Think of it as 0 over 1. If you take the reciprocal of 0, you get 1 over 0, which is just undefined. So the reciprocal of 0 is always going to be undefined, and the reciprocal of undefined is just 0. So again, instead of finding cosecant, we're really just finding the sine of 0, or the sine of 180 degrees, and then taking the reciprocal of that answer. Okay, here's our last 3. Please give them a try, and then hit play when you're ready to check. All right, go ahead and check your work here. So you can see that I went through the entire process. So here, for each one, so the reference angle here is 30 degrees, sine of 30 degrees is 1/2, but our answer should be negative, and then the reciprocal of that becomes negative 2. Here, I'm finding the cosine of 7 pi over 3, which is the same as the cosine of pi over 3, which is a nicer coterminal angle, which is just positive 1/2. It's in quadrant 1, and the reciprocal of that is positive 2. And here I'm finding the tangent of 360 degrees, and I'll take the reciprocal of that. Here's the coordinate at 360. And remember, for tangent, you do y over x, which is 0 over 1, and the reciprocal of that is undefined. All right, so that is all for today's lesson. Thank you so much for watching.